Welcome back to the Snoozy Scientist, a calm corner of the universe where curiosity and science drift together to put you to a calm sleep. Tonight, we're slipping beneath the waves into a world that feels so near to us and yet remains almost entirely unknown. The ocean covers more than 70% of our planet, yet less than 5% has ever been mapped in detail. The rest is a vast blank space, unmapped, unobserved, and unexplored. Even with satellites orbiting high above, even with our most advanced sonar and robotic explorers, most of what lies beneath remains a mystery. We know the surface of Mars more clearly than we know our own seabeds. To put it in perspective, only three people have ever reached the Challenger Deep, the deepest place on Earth. That's fewer than those who have walked on the moon. And down there, the rules of our world collapse. At just 1,000 meters, the last rays of sunlight vanish forever. Beyond that lies a night so complete it has lasted for millions of years. And yet somehow, impossibly, life thrives down there. Strange creatures that defy everything we once believed about how life should work. Entire ecosystems built not on sunlight, but on volcanic fire. With every dive, explorers return with forms of life we have never seen before. The ocean holds mysteries that remind us how little we know of our own home. Most of our ocean is still waiting to be discovered. But the haunting truth is that we may never be able to explore it all, not because we lack curiosity, but because of the challenges. So why can't we truly explore the ocean the way we dream of? What stops us, even in an age where we have built rockets and even sent robots to other planets? And why is the ocean, our own home, still humanity's greatest unknown? Tonight, we'll descend together into the dark side of the ocean to see what we know, what we don't, and why the sea may always hold secrets beyond our reach. But before we begin, I would love to know where in the world you're listening from and what the time is there. It is always fascinating to think of these stories being heard across so many different skies. If you enjoy these gentle journeys into Earth's mysteries, please do consider leaving a like and subscribing to the channel. A warm thank you as well to those of you who are already subscribed. You're helping this little corner of the internet grow. I do hope this story soothes you toward rest. Now take a deep breath, close your eyes, let your shoulders soften, and let's begin. When we look up at the night sky, the stars feel impossibly far away, yet strangely familiar. Through the lenses of telescopes, we can see the faint glow of galaxies billions of light years distant. We can trace the structure of swirling nebulae and measure the size of worlds that orbit stars far beyond our own. Space feels vast, but it also feels open to us, as if its mysteries are there to be collected one by one. What is astonishing, though, is that our ability to study these distant places often surpasses our ability to study what lies beneath the waves of our own oceans. The reason begins with the nature of light and water. Satellites soaring high above Earth can send radar beams across continents and deserts, mapping mountain ridges and river valleys with extraordinary accuracy. They can capture the craters of the Moon and the canyons of Mars in remarkable detail. But when that same signal meets the ocean, it cannot penetrate far. Water swallows light, it bends radio waves, and it scatters sound. To a satellite, the ocean is a shimmering shield, hiding everything beneath its surface. What satellites can do is measure the height of the water itself. In some places, subtle rises and dips in the sea reveal the hidden shapes of ridges and trenches deep below. These gravity-driven clues give us a rough outline of the seabed, a sketch in broad strokes. It is how we know the general shape of the Mariana Trench or the Mid-Atlantic Ridge, yet the detail is blurred, like looking at the shadow of a mountain rather than the mountain itself. When astronomers use space telescopes, They are peering into distances so vast that the numbers hardly seem real. Light traveling for billions of years still finds its way to our detectors. We can map the structure of the universe across time itself, capturing snapshots of galaxies as they were when Earth was young. In contrast, when oceanographers try to map the deep sea, they face limits that arrive within a few short kilometers. Sound, not light, is the tool of choice underwater. Sonar sends out pulses that bounce back from the seafloor. By measuring the time it takes for the echo to return, researchers can estimate depth and shape. Yet the ocean is immense, and sonar must be used painstakingly, ship by ship, across vast stretches of water. Even then, sound waves weaken with distance, and the deeper the ocean becomes, the harder it is to hear what lies below. What we end up with are fragments of maps, narrow corridors of detail stitched together over years, while the majority of the seabed remains a mystery. Consider Mars, a planet tens of millions of kilometers away. Through orbiting spacecraft, we have high resolution images of its surface. We can trace ancient riverbeds, measure the height of dormant volcanoes, and study the dust storms that sweep across its plains. Mars is barren, airless, and distant, yet we know it more intimately than the living seas of our own planet. Earth's seabed, by comparison, is patchy and incomplete, like a canvas that is mostly blank with only a few strokes of paint. This paradox captures the heart of the problem. Outer space, though unreachable for ordinary travel, is transparent to our instruments. The ocean, though it laps at our shores and stretches across most of the planet, remains stubbornly opaque. The tools that serve us so well in the cosmos falter in the face of water's density and depth. Each new technology we invent seems to highlight not just our progress, but also the scale of what remains undone. There is also the scale of time. A space probe orbiting a distant world can gather terabytes of data in a single pass, scanning wide regions in days. Mapping the seabed with sonar is like painting with a fine brush on a canvas the size of Earth. It takes not days, but decades, and still leaves most of the picture blank. And so we find ourselves in a strange position. We have mapped the red deserts of Mars in sharp relief, yet we cannot say with confidence what lies beneath the waves off our own coasts. We can peer at galaxies so ancient that their light began its journey before life on Earth began, but we cannot describe with certainty the creatures that swim just a few kilometers below us. It is this contrast that makes the ocean feel even more mysterious. The cosmos offers us a view, however distant, but the sea holds its secrets close. What we know of it are glimpses, shadows, and fragments, hints of landscapes and life forms that remain concealed. And as we move from this question of visibility into the deeper realities of the ocean itself, we must confront the barriers that lie not just in the limits of our instruments, but in the very nature of the deep. Because beyond the issue of mapping lies a greater challenge, the abyss itself, with its crushing pressure, its freezing cold, and its eternal darkness. The deeper one descends beneath the waves, the more the familiar rules of our world begin to unravel. What seems serene at the surface hides conditions so extreme that they test the limits of human engineering and imagination. Every meter down adds a new layer of challenge until the ocean becomes not just a body of water, but a vast fortress defended by pressure, cold, and darkness. The first of these barriers is pressure, an invisible weight that grows heavier with every step into the abyss. At the surface, we live under the gentle press of one atmosphere, the weight of the air above us. Yet for every 10 meters of depth, the ocean adds another atmosphere of force. By the time one reaches 1,000 meters, the body is already facing 100 times the pressure felt on land. To go deeper is to invite forces so immense they can crush steel and shatter glass. This is why submarines designed for deep exploration are so unlike the graceful vessels of fiction. They are not sleek, but shaped like spheres, because a sphere distributes pressure evenly. Their walls are thicker than bank vaults, forged from layers of steel and titanium. Even then, every descent carries risk, as the smallest crack or weakness could mean disaster. The Trieste, the first vessel to reach the Challenger Deep in 1960, had a window that cracked during its dive, a reminder that even the strongest designs are fragile when confronted with the weight of the deep. The pressure does not only challenge our machines, it transforms the very fabric of life. Creatures of the abyss have cell membranes reinforced with unique proteins and enzymes designed to withstand crushing force. Their bodies often contain no air-filled cavities that could collapse. For them, the pressure is not a danger, but a constant, the baseline of their world. For us, it is an almost insurmountable wall, separating our realm from theirs. Cold is the second barrier, creeping in long before the trenches are reached. Even in shallower depths, beyond the reach of the sun, the water temperature falls rapidly. At a few hundred meters, the warmth of the surface gives way to near freezing chill. The average temperature of the deep ocean hovers just above 0 degrees Celsius, a cold so steady it has shaped entire ecosystems. For humans, such temperatures mean hypothermia within minutes. For our machines, it slows electronics and hardens lubricants, turning every moving part brittle. Life here has adapted in strange ways. Many deep sea animals have slow metabolisms, conserving energy in the cold. Some produce antifreeze like proteins that prevent ice crystals from forming in their blood. Fish and invertebrates drift in near stillness, their survival depending on patience and efficiency rather than speed. The chill preserves the deep as a kind of natural archive, where the bodies of animals and the wrecks of ships can remain intact for centuries. For explorers, however, it means every mission must be equipped with heating systems and insulation just to keep equipment functioning against the silent freeze. Then comes the barrier that defines the abyss more than any other: darkness. Sunlight, that great enabler of life, fades quickly in water. At a few hundred meters, only a faint blue shimmer remains. By 1,000 meters, the last ray vanishes forever. Beyond this twilight zone lies an eternal night that no human eye has ever fully adjusted to. Here, the only light is made by life itself, flickers of bioluminescence glowing in the black, or the brief flash of an ROV's lamp as it drifts across the sea floor. This darkness is more than the absence of light. It is a realm where evolution has chosen strange paths. Many deep-sea creatures have eyes that are enormous compared to their bodies, wide lenses designed to capture even the faintest spark. Others have lost eyes altogether, adapting instead to vibration or chemical trails. For humans, darkness strips away bearings, leaving even the most advanced submersibles dependent on instruments rather than vision. The ocean floor here is mapped by sonar pings and the dim glow of artificial lamps, never by natural sight. To face all three barriers together, pressure, cold, and darkness, requires a level of engineering that borders on the impossible. Every descent into the deep demands not just a vessel strong enough to endure the crushing weight, but also systems that can withstand freezing temperatures and navigate a world without light. Even then, the ocean resists us. Voyages are rare, costly, and brief. For the most part, the abyss remains untouched, a reminder that the sea does not give up its secrets easily. Yet, it is precisely these barriers that give the deep its aura of mystery. Each time we try to descend further, we are reminded not only of how harsh this environment is, but of how much life has already adapted to it. For every wall that seems unbreakable to us creatures have found a way to thrive, turning the abyss into their home. And as the story of the ocean unfolds, the next question that lingers is what landscapes lie hidden in these depths, the great scars and trenches of Earth that have been touched by human presence only a handful of times. Far beneath the rolling waves, hidden from the reach of sunlight and the warmth of the surface, the seafloor drops away into vast chasms that cut into the very crust of the earth. These are the deep ocean trenches, some of the most extreme and least explored places on our planet. They are scars left behind by tectonic forces, where one plate of Earth's crust slides beneath another, pushing rock downward into the mantle. The result is a wound in the planet's surface, stretching for hundreds of kilometers and plunging to depths greater than the height of mountains. The most famous of these is the Mariana Trench, lying quietly in the Pacific Ocean. At its deepest point, known as the Challenger Deep, the seabed sinks nearly 11 kilometers below the surface. To imagine this depth, picture Mount Everest, the tallest mountain on Earth, inverted and placed within the trench. Even then, its peak would still be swallowed by more than 2 kilometers of water above it. It is a place so remote and so hostile that only a handful of humans have ever seen it with their own eyes. The first attempt came in 1960 when the bathyscaphe Trieste carried Jacques Picard and Don Walsh into the darkness. Their descent lasted nearly 5 hours as the tiny vessel creaked under unimaginable pressure. When they finally reached the bottom, they glimpsed a flat plain of silt, stirred by their landing. Through a small porthole, they reported seeing life even there, small creatures moving in the gloom. Then, after just 20 minutes, they began their long journey back upward, leaving the seafloor as untouched as they had found it. It would take more than 50 years before another human returned. In 2012, filmmaker James Cameron descended alone in a custom-built submersible. His vessel, the Deep-Sea Challenger, was a tall, narrow craft designed to withstand the crushing forces of the trench. He spent hours exploring, gathering images and samples that revealed a barren but hauntingly beautiful world. Yet his dive, like those before it, covered only the tiniest fraction of the trench, a single pinprick in a vast abyss. Since then, only a few more dives have been made, often by experimental vessels or privately funded missions. The number of people who have visited Challenger Deep is still fewer than the number who have walked on the moon. Each descent is a feat of engineering, requiring vessels with walls thicker than vault doors, systems to withstand freezing cold, and instruments that can function in total darkness. But the Mariana Trench is only one among many. There are more than 20 known deep-sea trenches around the world, from the Tonga Trench in the South Pacific to the Puerto Rico Trench in the Atlantic. Many of these are nearly as deep as the Mariana, yet most remain unmapped and unexplored. They are immense gashes in the Earth's surface, hidden beneath miles of water, holding landscapes as dramatic as the highest mountain ranges. Steep cliffs, winding valleys, and towering geological formations lie there, unseen and untouched. What little we know of these trenches often comes not from direct observation, but from remote instruments. Deep-towed sonar has revealed hints of strange shapes, while robotic submersibles have captured brief images of otherworldly creatures drifting in the void. Amphipods the size of human hands, translucent snailfish, and microbial mats clinging to rocky walls have all been found in these depths. Yet every expedition returns with more questions than answers. The scale of what remains unseen is overwhelming, as if we are staring at a door that has only been opened a fraction of an inch. These trenches are not only biological frontiers, but geological ones. They mark the boundaries of tectonic plates, where Earth reshapes itself in silence. Earthquakes often rattle along these lines, and tsunamis are born in their shadows. Entire mountain ranges rise and fall because of the slow grinding at their edges. Yet we have no detailed maps of these landscapes, no clear understanding of their hidden structures. For now, they remain like distant rumors, places that belong to science fiction as much as to science fact. And so, even though the ocean surrounds us, the truth is that its deepest places are still beyond our grasp. We have only skimmed the surface of these immense abysses, barely touching their edges, while their vast interiors remain cloaked in mystery. With every passing year, our technology improves, yet the trenches remind us how much remains unknown and how fragile our efforts are against the weight of the sea. As we drift deeper into this story, the question that lingers is not only what these great gashes in Earth's crust look like, but also what lives within them. For in these dark recesses of the planet, life has found a way to endure against all odds, surviving in conditions that seem utterly impossible. And it is to these creatures, fragile and extraordinary, that our attention now turns. For as long as humans have sailed the seas, there have been whispers of strange beings rising from the depths. Sailors told tales of tentacles as thick as tree trunks wrapping around ships, pulling them into the black waters below. For centuries, these stories lived in the space between fear and imagination, dismissed by many as myth. And yet, in recent years, we have learned that the truth was not so far from the legends. The giant squid, once a creature of maritime folklore, has been confirmed to exist, not in sailors' tales, but in flesh and blood, with bodies stretching over 12 meters and eyes larger than a human head. These animals remind us that the ocean has always kept its secrets well. For most of history, we never saw them alive. What little we knew came from carcasses washed ashore or fragments hauled up in fishing nets. It was only in the early 21st century that cameras finally captured a giant squid in its natural home, gliding silently through the midnight waters. Even now, so much of its life remains a puzzle, its behaviors hidden from us in the abyss. The giant squid is not alone. The deeper one goes, the stranger the ocean becomes, as though each layer is another universe entirely. Down in the abyss, where light has never reached, creatures have been forced to adapt in ways that defy our expectations. Their bodies are shaped by the extremes of pressure, cold, and perpetual night. Many are translucent, their forms ghostly and delicate, blending into the water around them. Some have evolved to produce their own light, creating living lanterns to lure prey, attract mates, or confuse predators. Others are slow-moving scavengers, conserving energy in a world where food is scarce, where the fall of a whale carcass from the surface above can feed entire communities for decades. Every dive into these depths reveals something new. Remote operated vehicles, or ROVs, have allowed us to glimpse into the abyss more often than humans themselves ever could. With cameras, mechanical arms, and bright lights, these machines drift down where pressure would crush steel and where the cold can freeze most forms of life. And each time they descend, they capture images of animals never seen before. Scientists have estimated that the majority of species in the deep sea remain undiscovered, their forms still hidden in the folds of trenches and the cracks of seafloor mountains. It is as if the ocean is a book we have barely opened, each page offering another revelation. Some of these discoveries are both beautiful and unsettling. Jellyfish with tendrils trailing dozens of meters behind them drift like underwater galaxies. Fish with transparent heads and eyes that peer upward through their skulls watch the faintest glimmers of light above. Shrimp with glowing patterns dotting their bodies move in coordinated displays like living constellations. And yet, for every strange creature we catch a glimpse of, There are countless more that vanish back into the darkness before we can study them. The challenges of observing these beings mean that we often know only fragments of their stories. A fish seen for a few seconds on a camera might never be encountered again. A sample drawn from the depths may not survive long enough for us to understand its way of life. Entire ecosystems thrive in conditions that seem alien to us, yet the more we uncover, the more questions seem to unfold. How do these creatures breed in the dark? How do they navigate in silence without landmarks or light? And perhaps most mysterious of all, how many of them are out there, waiting in regions of the ocean where no machine has yet ventured? It is humbling to realize that even in an age of satellites and global networks, the most abundant habitat on Earth is still a frontier of myth. The ocean cradles millions of years of evolution, shaping bodies and behaviors that have never been witnessed by human eyes. Somewhere in the black corridors of trenches and the sweeping plains of the abyss, there are creatures so strange they may challenge our very ideas of what life can be. Each ROV dive, each fleeting glimpse into the unknown, is a reminder that our planet is not fully mapped, not fully cataloged, not fully known, and as we continue our journey downward, it becomes clear that the sounds, sights, and signals of the deep carry just as much mystery as the creatures themselves. For the ocean is not silent, and what we have heard from its depths is as haunting as the beings that drift through it. The ocean is often described as silent, but in truth, it is anything but. Beneath the surface, sound becomes the dominant force. Waves breaking, whales singing, shrimp snapping, and currents rushing against the seafloor all merge into a hidden symphony that fills the dark waters. Unlike light, which fades after only a few hundred meters, sound travels astonishingly well in water. A low-frequency noise can cross entire oceans, bouncing through what scientists call the sound channel, a deep layer where sound can travel for thousands of kilometers without weakening much. It is here, in this hidden highway of sound, that some of the most mysterious signals ever recorded have been heard. One of the most famous of these is known simply as the bloop. It was detected in the summer of 1997 by hydrophones that had originally been placed across the Pacific Ocean during the Cold War to listen for submarines. The noise was unlike anything expected. It rose in pitch, almost like a living creature's call, and it was so loud that sensors more than 5,000 kilometers apart all picked it up. At first, no known animal could explain it. Blue whales, the loudest animals on Earth, did not produce sounds at such a pitch, and the sheer volume of the bloop seemed impossible for any known creature. For years, the mystery lingered, sparking speculation that perhaps there were giants in the deep, unlike anything we had ever seen. Later, many scientists suggested it might have been the sound of icebergs cracking and moving, but the legend of the bloop remains, because in the ocean, the line between explanation and enigma is never clear. Not long after, another strange signal was given a name. It was called Julia, a long, mournful moan recorded in 1999. The sound carried on for nearly 15 seconds, echoing through the Pacific. Some suggested it too was the sound of ice breaking, but others could not shake the eerie impression that it resembled a cry, as though the ocean itself had sighed. What made it so compelling was not only its haunting tone, but the way it reminded us that water, with its immense ability to carry sound, could easily disguise the true source of a signal. Julia, like the bloop, left behind more questions than answers. Then came upsweep, a name given to a repeating series of sounds first detected in 1991. Upsweep consists of long rising tones, almost like the sweeping call of some unknown instrument. It has been heard seasonally ever since, usually strongest in spring and autumn, but its source has never been identified. The consistency of its pattern makes it unlikely to be random noise. Some have proposed volcanic activity, as the area where it was detected lies along the fault lines of the Pacific. Others suspect biological origins, some rhythm of life we have yet to encounter. Upsweep continues to puzzle researchers, a signal without a clear sender. There are many more, scattered across decades of listening, whistles, groans, bangs, and hums that appear suddenly in the hydrophone recordings and then vanish without warning. Some of them have eventually been tied to natural events like undersea earthquakes, shifting ice, or the movements of storms, yet many remain unexplained. In the depths where pressure crushes and light never reaches, sound is the only witness, carrying whispers of events and beings we cannot see. These ghost sounds remind us how little we know of the ocean's interior. They also reveal just how powerful sound is beneath the sea. While on land it is light that defines our sense of space, in the ocean it is vibration, echo, and resonance. Whales use it to find one another across entire ocean basins. Submarines once relied on it for stealth and survival, and hydrophones, placed to guard against conflict, have instead given us a window into mysteries no one anticipated. Each unexplained sound leaves a trace of wonder, because in a world as vast and hidden as the sea, any signal might belong to something we have never encountered. The bloop, Julia, upsweep, and countless others are not just noises in the dark. They are reminders that the ocean is alive with voices, some familiar and some forever beyond our reach. And while the hydrophones keep listening, the sea continues to whisper its secrets, inviting us deeper into its story, where new discoveries wait with every descent. In the deepest waters of the ocean, where sunlight has long since vanished and darkness stretches without end, there is still light born from life itself. It shimmers and pulses, flickers and waves, and dances across the bodies of creatures that seem as though they belong to another world. This is bioluminescence, a phenomenon so widespread and yet so mysterious that scientists are only beginning to understand its full scope. Bioluminescence is not rare in the ocean. In fact, the majority of deep-sea animals are thought to have some form of it. It is created through a chemical reaction inside the body, where a molecule called luciferin reacts with oxygen, often triggered by an enzyme named luciferase. The reaction releases energy in the form of light, glowing in blues and greens that travel far through seawater. To those who witness it, the effect is almost magical, yet it is entirely natural, honed by evolution over millions of years. The uses of this living light are as varied as the creatures themselves. Some use it to hunt. The anglerfish, drifting in the black waters, dangles a glowing lure in front of its mouth. Small prey, curious or fooled by the glow, drift closer until the predator snaps its jaws shut. Others use bioluminescence as a shield. When startled, some squid release clouds of glowing ink, confusing attackers and giving them time to escape. Certain fish flash dazzling bursts of light, startling predators into retreat. Even tiny plankton, disturbed by a passing boat, glow in waves so bright they can be seen from space, turning entire stretches of ocean into glowing fields of blue. Communication is another secret of this light. In the darkness, vision is limited, so some animals use bioluminescence as a language. Flashing patterns can signal readiness to mate, mark territory, or help members of the same species recognize one another. Some deep-sea shrimp flash coded bursts of light, while lanternfish use glowing patches on their bodies like identification tags. Each flicker, each shimmer, carries meaning in the silent black. Perhaps the most haunting are the displays that seem purely artistic. Whole schools of fish ripple with light as they move, like constellations shifting across the sea. Comb jellies, fragile as glass, scatter rainbows of iridescence across their bodies as they drift. Sometimes, a single creature can appear as a floating galaxy, with sparks of blue or green running along its translucent form. These sights remind us of just how alien the deep ocean can feel, even though it is part of our own planet. What is striking is how much we still do not know. For many species, the exact reasons for their light remain uncertain. Why would a tiny worm glow bright red in an environment where red light disappears almost instantly? Why do some jellyfish flash in patterns so complex they seem almost designed? Each discovery raises more questions, and each expedition brings back new examples of creatures lighting the dark in ways we never imagined. The adaptability of bioluminescence is also remarkable. It is found in organisms across the spectrum of life, from microscopic bacteria to giant squid. This suggests that the ability to produce light has evolved independently many times, always as a solution to the challenges of darkness. It is not one invention, but many, each shaped by the environment, each offering a different answer to survival in the abyss. The wonder of this light is not confined to the very deepest seas. Even in coastal waters, on warm nights, swimmers sometimes leave glowing trails with every movement, as clouds of tiny plankton respond to disturbance. Waves break in bright streaks along the shore, and the footprints of crabs glow on the sand. These smaller displays are echoes of the vast light show hidden far below, reminders that the ocean carries more secrets than we can see. To think that in the absence of the sunlight, life has created its own form of day, its own lanterns in the dark, is both humbling and extraordinary. Bioluminescence turns the deepest ocean into a shifting, glowing theater where survival, communication, and beauty all take place in silence. And as we drift further into this story, it becomes clear that even stranger layers of the sea await us, where neither day nor night exists, but something in between. Between the sunlit shallows and the eternal night of the deep lies a realm unlike any other on Earth. Scientists call it the mesopelagic zone, but it is more poetically known as the twilight zone. It stretches from about 200 meters below the surface down to nearly 1,000. Here, light does not vanish all at once, but instead thins into a dim and ghostly glow. Sunlight filters down faintly, enough to blur the outlines of shadows, yet never bright enough to sustain the green of plants. It is a place that is neither day nor night, a shifting boundary that is home to some of the most elusive life on the planet. The twilight zone covers a vast expanse, encircling the globe like a hidden belt of mystery. Though invisible to us at the surface, it is immense, containing more living biomass than all the world's rainforests combined. Within its shadowy waters swim countless fish, squids, jellyfish, and planktonic creatures, many of which have never been captured or studied. Their shapes are tuned to the gloom. Some have sleek, silver sides that reflect the faint light, blending perfectly into their surroundings. Others are dark, almost invisible, their bodies vanishing into the black beneath them. Many carry their own lanterns, small points of bioluminescence that flash and flicker like stars in a liquid sky. Every evening, as the sun sets and darkness blankets the ocean, the twilight zone comes alive with the greatest migration on Earth. Billions of fish and invertebrates rise from these depths toward the surface, a mass movement so vast that it can be seen from space as shadows shifting beneath the waves. By day, they remain hidden in the deep, safe from predators. By night, they rise to feed on plankton near the surface, their shimmering bodies following the rhythm of the planet. This daily journey, repeated again and again, may involve more animals than all the herds and flocks on land combined. Yet for most of history, humanity never knew it was happening. The creatures that live here are adapted to an environment that is both delicate and extreme. Many have enormous eyes, tuned to capture the faintest hints of light or upward facing vision to spot the silhouettes of prey above them. Others use counter illumination, glowing on their undersides so that they match the faint sunlight filtering down from above, making their outlines disappear from view. Some species conserve energy by drifting slowly, moving as little as possible in waters where food can be scarce. And then there are those that hunt with light itself, using flashes to lure prey or to confuse it long enough to strike. For all its abundance, the twilight zone is still almost entirely unexplored. Its depths are too shallow for satellites to see, but too deep for most submersibles to linger. Nets brought up from the zone often crush or kill the delicate animals they capture, leaving us with fragments rather than whole specimens. Cameras can only penetrate so far before the pressure, cold, and darkness overwhelm them. What we know comes from fleeting glimpses, from short expeditions, and from the shadows caught on sonar. In truth, we have studied only a fraction of this immense habitat. What little has been learned suggests that the twilight zone may play a critical role in the balance of our planet. When its creatures rise at night to feed, they bring carbon with them, moving it from the surface toward the depths when they return by day. This vertical transport, repeated every 24 hours by billions of animals, helps regulate the climate itself. Yet the scale of this process is still poorly understood because the very animals performing it are largely unknown. To drift into the twilight zone is to enter a dreamlike place, suspended between light and dark, where the boundaries of life blur into shadow. It is a realm of enormous abundance, yet also one of invisibility, tucked just out of reach of human eyes. And as we travel deeper into the ocean's mysteries, we begin to uncover not just layers of water, but layers of life, each more astonishing than the last. In the late 1970s, a team of oceanographers lowered a submersible into the dark waters off the Galapagos Islands. Their mission was simple: to explore a section of the seafloor that lay along a mid-ocean ridge where the Earth's crust was slowly pulling apart. No one expected to find anything extraordinary. The deep ocean was thought to be barren, a desert where life could not survive without sunlight. Yet in 1977, when their lights illuminated the seafloor, the world of science was transformed. What they discovered were hydrothermal vents, fissures in the Earth's crust where seawater seeps deep into the hot rock below, is superheated, and then bursts back out, carrying with it minerals and chemicals from beneath the crust. These vents looked like underwater chimneys, some rising as tall as buildings, spewing dark clouds into the water. Around them, to the astonishment of the scientists, was life. Not a handful of scattered organisms, but entire thriving ecosystems clinging to the edges of these black smokers, glowing softly in the beams of the submersible's lights. Giant tube worms clustered in dense colonies, their red plumes swaying in the currents. Clams the size of dinner plates covered the rocks. Strange crabs scuttled across the vent openings, and fish swam in and out of the shimmering water. It was a revelation, a community of life existing entirely without sunlight. For all of Earth's history, it had been assumed that photosynthesis was the foundation of every ecosystem, that without the sun there could be no food chain. Yet here, in the crushing darkness of the deep, life had found another way. The secret was chemistry. At these vents, bacteria used hydrogen sulfide, a compound toxic to most animals, as their energy source. Instead of photosynthesis, which relies on light, they performed chemosynthesis, building sugars and sustaining themselves entirely on chemical energy. These bacteria became the foundation of the vent ecosystem, feeding tube worms, clams, and countless other creatures that had adapted to thrive in this environment. What had once seemed a desert was, in fact, a cradle of abundance, all powered by the Earth's inner heat. The discovery of hydrothermal vents raised profound questions about the origins of life. If life could exist here, thriving in complete darkness and under pressures unimaginable at the surface, then perhaps the earliest forms of life on Earth had emerged in places like this. The vents provide not only energy but also shelter, with mineral-rich chimneys forming microenvironments where molecules could gather and react. Some scientists believe these vent systems may have been the very birthplace of biology, where simple chemistry crossed into complexity and gave rise to the first living cells. The idea stretches even further. If Earth's ocean can host such thriving ecosystems without sunlight, then perhaps other worlds could too. Moons like Europa and Enceladus, orbiting far from the Sun, are believed to have liquid oceans hidden beneath thick shells of ice. If hydrothermal vents exist on their seafloors, as many models suggest, then life might not be limited to Earth alone. Chemosynthesis could be the universal answer to survival in places where light can never reach. Each new expedition to hydrothermal vent fields reveals stranger adaptations. Tube worms, for example, have no mouths and no digestive systems. Instead, they house symbiotic bacteria within their bodies, allowing them to feed directly on the products of chemosynthesis. Vent shrimp have light-sensitive patches on their backs that may detect the faint glow of hot fluid shimmering in the blackness. Even the chimneys themselves, built from minerals carried up from beneath the crust, become fragile ecosystems, each one a monument of rock and life standing in the abyss. Despite their richness, hydrothermal vents remain fragile. The same mineral deposits that make them so unique have attracted human interest, particularly in deep-sea mining. Metals like copper, zinc, and even rare earth elements accumulate in the chimneys, tempting industries that see the deep as a frontier for extraction. But these ecosystems are young and delicate, sometimes lasting only decades before shifting or collapsing. To disturb them could erase communities we barely understand and species we have not yet discovered. What is most striking about hydrothermal vents is the reminder that life is not limited by the rules we once thought were absolute. Without the sun, without plants, and without the familiar cycles of land and air, living systems not only survive but flourish. They remind us that the ocean's mysteries are not only about strange creatures or unreachable depths, but also about the very story of life itself. And as we drift deeper into that story, new layers of the sea begin to unfold, carrying us further into the unknown. When we look beyond Earth, past the swirl of clouds and the blue curve of our oceans, we find other worlds that seem barren at first glance. Cold, airless moons circling giant planets, their surfaces frozen solid, yet beneath their crusts of ice, scientists now believe there are hidden seas, vast reservoirs of liquid water sealed away in silence. Europa, the bright moon of Jupiter, is one of them. Cracks stretch across its icy surface, scarred by tides so powerful that they heat its interior. Beneath those fractures lies an ocean that may be more than 100 kilometers deep, containing more water than all of Earth's oceans combined. Enceladus, a smaller moon of Saturn, offers its own evidence. In 2005, the Cassini spacecraft flew past it and discovered geysers erupting from its south pole, fountains of water vapor and ice crystals shooting into space. These plumes come from a global ocean beneath its crust, warmed by the friction of tidal forces. The water carries salts and simple organic molecules, hints that chemistry is at work in the darkness below. Then there is Titan, Saturn's largest moon, a place so strange that it blurs the boundary between the familiar and the alien. On Titan, rivers and lakes of methane and ethane flow across its surface, while beneath its icy shell, an ocean of water mixed with ammonia is thought to exist. What makes these discoveries so haunting is how much they echo our own world. On Earth, beneath crushing pressure and total darkness, hydrothermal vents pour out heat and minerals, creating habitats where life thrives without sunlight. If such environments exist on Europa or Enceladus, then they may host their own ecosystems. Chemosynthesis, the same process that powers life at our vents, could be a universal strategy. The blueprint is already here, hidden in our oceans. But if the oceans on our own planet remain mostly unexplored, how can we hope to uncover what lies beneath the ice of distant moons? On Earth, we have only touched the edges of the abyss. Each dive reveals new species, new landscapes, and new mysteries, even though the oceans surround us on every side. Now imagine the challenge of sending probes across hundreds of millions of kilometers, drilling through ice thicker than any glacier, and lowering instruments into seas we cannot see. The complexity is staggering, and yet the possibility pulls at us like gravity itself. When scientists study Earth's deep seas, they are not only learning about our planet, they are rehearsing for journeys beyond it. The strange microbes that live on chemicals instead of sunlight, the ghostly fish that drift in the twilight zone, and the creatures that glow with living light all teach us what is possible in worlds cut off from sunlight. Each expedition to a hydrothermal vent or a polar sea is a glimpse into conditions that may exist on Europa or Titan. Our ocean becomes a living laboratory, the only model we have for imagining life elsewhere. These alien oceans stir questions that feel both scientific and deeply human. Could life exist in places so far removed from the warmth of a star? Would it resemble the creatures we know, or would it take forms beyond anything we have seen? If we one day send a submarine beneath Europa's crust, will it drift past glowing shoals of plankton-like beings, or find barren rock swept only by currents? The answers lie hidden, waiting in waters that may have been undisturbed for billions of years. The dream of reaching these oceans is one of exploration at its most daring. It asks us to go not only farther than we ever have, but deeper than we have ever managed. Before we pierce the ice of distant moons, we must learn to understand the secrets of our own seas, because here on Earth, the same story is unfolding in silence. What we discover in our oceans does not only belong to us, it may be the key to recognizing life when we finally encounter it beyond our world. And so, the mysteries of the deep sea and the mysteries of the stars are bound together, reflections of the same enduring question: what does it mean for a planet or a moon to be alive? Beneath the rolling waves, far below the reach of sunlight, the seafloor is not still, it is alive with fire. The Earth's crust is thin in these places, fractured and restless, allowing heat from the mantle to escape. More volcanoes lie hidden beneath the ocean than on all the continents combined. Some estimates suggest that 3/4 of all volcanic activity on Earth happens underwater, silent and unseen. These submarine volcanoes rise from the abyss like mountains of molten rock, their slopes cloaked in darkness, their summits sometimes reaching high enough to pierce the surface and form new islands. Along the mid-ocean ridges, where tectonic plates slowly pull apart, chains of volcanoes stretch for tens of thousands of kilometers. These ridges weave across the planet like scars, longer than any mountain range on land. Here, magma wells up from beneath the crust, creating new seafloor in a process that never stops. Every year, a thin layer of fresh basalt spreads outward, and the continents shift ever so slightly, carried along by the churning mantle below. If you could see it from above, the ocean floor would appear like a great zipper opening slowly, releasing both fire and life into the deep. Eruptions under the sea are different from those on land. When molten rock meets the cold water, it cools instantly, forming strange rounded shapes known as pillow lavas. Clouds of superheated water and minerals billow upward, mixing with the cold and creating plumes that rise hundreds of meters before dispersing. Sometimes the eruptions are small, hidden even from detection. Other times, they are massive, powerful enough to reshape entire landscapes in the dark. When such eruptions occur near the coasts or shallow seas, they can send shock waves through the water, triggering tsunamis that reach faraway shores. Because so many of these volcanoes are buried under kilometers of water, they are almost impossible to study directly. The pressure crushes most equipment, the darkness makes navigation difficult, and the heat around eruptions can destroy delicate instruments. What we know often comes from indirect evidence: seismic sensors picking up distant rumbles, satellite images detecting changes in the sea surface, or occasional expeditions that stumble upon newly formed lava fields. Every discovery reminds us how much of Earth's geology is hidden below, uncharted and active. One of the most dramatic examples happened in the Pacific in 2009, when scientists studying the Lau Basin captured images of an undersea eruption in progress. Through the lens of a remotely operated vehicle, they watched fountains of lava spewing into the water, glowing orange even as the surrounding sea boiled into white clouds. It was a glimpse of creation in real time, a vision of how continents were built and how Earth continues to evolve. These volcanoes are not just destructive forces. Around their flanks, life has learned to adapt. Hydrothermal vents, which often form near volcanic activity, release heat and chemicals that sustain unique ecosystems. Shrimp, crabs, and worms gather in vast numbers, feeding on the bacteria that turn chemical energy into food. In a place that seems so hostile, life flourishes, proof that Earth's most dangerous landscapes can also be among its most fertile. Still, the hazards are undeniable. When volcanoes collapse or shift, they can create landslides that displace vast volumes of water. These sudden movements can generate tsunamis far more devastating than those triggered by earthquakes alone. The Indian Ocean tsunami of 2004, though caused primarily by a tectonic shift, was influenced by submarine activity along the fault zone. It is a reminder that what happens on the seafloor can ripple outward to change lives on distant coasts. What makes the study of submarine volcanoes so challenging is also what makes them so mysterious. They lie in places we can rarely reach, on landscapes we have barely mapped. Each one is a hidden mountain, a silent architect of the planet, shaping coastlines and oceans without our knowing. And as we drift further into the deep, we find that the forces at work beneath the waves are not only sculpting the surface of Earth, but also writing the planet's history in fire and stone. For centuries, sailors spoke of monstrous waves that rose out of calm seas without warning, walls of water taller than any ship, striking with such sudden force that entire vessels were swallowed. These accounts were passed down as sea stories, often dismissed by scientists on land as exaggerations, the wild imaginations of weary travelers. For a long time, rogue waves were regarded as myths, belonging to the same realm as sea serpents and phantom ships. Yet in recent decades, the ocean revealed that these invisible giants are very real. In 1995, a wave struck an oil platform in the North Sea. Instruments recorded its height at over 85 feet, towering higher than the rig itself. The wave came out of nowhere, far larger than the seas around it, and it matched the very descriptions that sailors had given for centuries. This was the first time such an event had been captured with precise data, and it forced the scientific community to reconsider the stories they had once dismissed. Since then, satellites scanning the surface of the oceans have confirmed that rogue waves are not rare accidents, but regular visitors, roaming the seas silently. A rogue wave can rise more than 100 feet high, taller than a 10-story building. Unlike tsunamis, which are triggered by earthquakes or landslides, rogue waves form suddenly in open water, often when smaller waves combine in just the right way, stacking their energy until a single monster towers above the rest. Their lifespan may be short, but their impact is enormous. A ship caught in the path of such a wave can be torn apart before a distress signal is even sent. Some of the vessels reported lost in fair weather, without clear cause, may have been victims of these sudden walls of water. The mystery of rogue waves deepens when one considers how long they remained unproven. Despite centuries of eyewitness accounts, there was little evidence until modern technology made it possible to record the sea surface with radar and satellites. When researchers began analyzing these patterns, they found dozens of such waves forming across the oceans every year. Some appeared in the South Atlantic, others in the Pacific, and many more in regions like the North Sea, where storms and currents collide. It was not myth after all. It was a reality hiding in plain sight, only too fast and too fleeting to leave much trace behind. Yet rogue waves are not the only giants the ocean hides. Even more catastrophic are megatsunamis, events so rare and violent that they defy comparison. Unlike ordinary tsunamis, which already carry unimaginable power, a megatsunami can rise to heights beyond 300 feet. These are not triggered by shifting plates beneath the seafloor, but by sudden, colossal displacements of water. A landslide crashing into a bay, a volcanic eruption collapsing into the sea, or even an asteroid strike can generate waves that tower over coastal mountains. One such event occurred thousands of years ago in Alaska, when a massive landslide fell into Lituya Bay. The wave that followed stripped trees from slopes more than 1,500 feet above sea level, the highest wave ever recorded on Earth. The terrifying thought is that these forces still exist today. The Canary Islands in the Atlantic, with their volcanic slopes, have been studied as potential sources of future megatsunamis. A collapse there could send waves across the ocean, striking the eastern seaboard of North America with devastating effect. While the likelihood of such an event in our lifetimes may be small, the possibility remains, reminding us that the ocean holds powers beyond even the worst storms. What ties rogue waves and megatsunamis together is their invisibility until the moment they arrive. A calm sea can conceal the seeds of chaos, energy building silently beneath the surface until it converges into a single, towering wall. For those who witness such an event, there is little warning, only the sudden appearance of water rising higher than imagination allows. These giants, invisible until they strike, remind us that the ocean is not just vast and mysterious, but also a place where scale itself seems to bend. And just as the seas carry these hidden colossi, they also hide regions where life itself begins to vanish, places where the oxygen that sustains animals disappears, leaving silent zones that are as deadly as any wave. Not all mysteries of the ocean are hidden in its depths. Some of the most unsettling are found much closer to the surface, in places where life itself quietly fades away. These are known as oxygen dead zones, vast stretches of water where oxygen levels fall so low that large animals cannot survive. Fish, crabs, and squid all flee or perish, leaving behind waters that feel eerily empty. What remains are only the smallest and hardiest of microbes, clinging on in conditions where oxygen has vanished almost completely. The ocean is alive with motion, currents stir its layers, storms churn its surface, and waves mix oxygen into the water. But in certain regions, this balance collapses. When nutrient-rich runoff from rivers enters the sea, it feeds enormous blooms of algae. At first, the water may seem more alive than ever, teeming with green plankton under the sunlight. Yet as the algae die, they sink into deeper layers, where bacteria break them down. That process consumes oxygen, stripping it from the water until little remains. The larger animals suffocate, and the sea becomes strangely still. These zones can span immense distances. In the Gulf of Mexico, one dead zone often grows each summer to cover an area as large as some countries. Similar regions appear off the coasts of India, South America, and Africa, where rivers carry fertilizers and waste into the sea. Climate change adds another layer of strain. As surface waters warm, they become less able to mix with cooler layers below. Without this mixing, oxygen cannot reach the deeper parts, and the suffocating conditions spread further. Year by year, the dead zones expand, turning once vibrant ecosystems into ghostly deserts. For explorers, these places present unusual challenges. Submersibles and remotely operated vehicles rely on oxygen sensors and delicate instruments, many of which fail in waters so depleted. The chemical balance of dead zones can corrode metal, damage electronics, and limit visibility. Equipment that functions well in the open sea can falter quickly here, adding to the difficulty of studying regions that resist intrusion. Even the act of diving into these waters is unsettling. Where life usually thrives, silence takes its place, as though the sea itself has been muted. The creatures that do endure here are striking examples of adaptation. Certain microbes survive without oxygen by relying on chemical processes that produce energy from nitrogen, sulfur, or methane. Some release toxic byproducts, creating layers of water so hostile that little else can exist. These microbial communities may seem simple, yet they play an important role in shaping the chemistry of the ocean. They remind us that life is stubborn, finding ways to persist even when conditions collapse. Still, what flourishes here is nothing like the abundance seen elsewhere, and the absence of fish or whales in these waters is deeply felt. Dead zones are not always permanent. Storms, shifting currents, or changes in temperature can stir the layers of water and restore oxygen, allowing animals to return. But as climate change accelerates and human activity continues to add nutrients to the seas, these suffocating areas are appearing more often and lasting longer. They are signs of a fragile balance being tipped, warnings that the ocean can lose its breath. To imagine the sea, without its great shoals of fish, without the darting of squid or the slow drift of jellyfish, is to imagine an ocean silenced of much of its wonder. Yet these places are real, spreading quietly beneath the waves, and as we drift from them into the wider ocean once more, we find other shadows waiting, not from a lack of oxygen, but from the presence of something that should never have been there at all. Plastic carried into the deepest trenches of the world. The deep ocean has long been imagined as a place beyond human reach, untouched by the noise and chaos of life on land. For centuries, it seemed unthinkable that anything we created could travel so far, slipping into the trenches and settling on the seafloor miles below the surface. Yet when scientists began sending robotic explorers into the world's deepest chasms, What they found was unsettling. Even in the Mariana Trench, more than 10 kilometers beneath the waves, fragments of plastic were discovered. They were tangled in sediments, floating in the water column, and even inside the bodies of animals collected from the abyss. These fragments are called microplastics, tiny particles less than 5 millimeters across, often invisible to the naked eye. They form when larger pieces of plastic, like bottles, bags, or fishing nets, break apart under sunlight and waves. Carried by currents, they drift across the seas, sinking slowly until they scatter across the deepest valleys of the planet. They are so light that they can float for years, yet so persistent that they may never fully disappear. The very durability that once made plastic so useful has turned it into a haunting presence in every corner of the ocean. What makes this discovery so striking is not just where the plastic has ended up, but how it moves through living things. Deep-sea amphipods collected from the Mariana Trench were found to have ingested microplastic fibers, their translucent bodies carrying threads that had no place there. Mussels from coastal waters contain them in their tissues. Fish pulled from mid-ocean depths show the same fragments inside their stomachs. Even plankton, the foundation of the ocean food chain, have been seen consuming these particles, mistaking them for food. This means that plastic is not just settling into the seabed, but flowing through the very systems that sustain life. The sheer scale of the problem is difficult to comprehend. Scientists estimate that billions of tons of plastic have been produced since the mid-20th century, and much of it has ended up in the sea. Some gathers in vast gyres on the surface, forming floating patches that stretch for hundreds of kilometers, yet more sinks, unseen, into the deep. In some places, sediment cores pulled from the seabed reveal layers rich with plastic fibers, a new geological marker of our time. If future civilizations ever study these rocks, they will find the signature of our age written in polymers. Even the most remote and seemingly pristine waters are no longer untouched. Plastic particles have been detected in the Arctic and Antarctic, carried by winds and currents across entire hemispheres. They fall with rain, drift with snow, and settle into the very ice that locks the polar seas. Each discovery deepens the haunting question: how can we hope to study the ocean as it truly is when we have already changed it so profoundly? For explorers and scientists, this contamination creates both a challenge and a paradox. Instruments lowered into the deep often return with samples that are already compromised, the tiniest plastic fibers clinging invisibly to the water. Even laboratories must take care not to introduce more plastic into what they are studying. The line between natural and artificial blurs, leaving us to wonder what the deep ocean looked like before our presence reached it. And yet, despite the weight of this knowledge, there is also resilience. Life in the deep continues, adapting in ways we do not yet understand. Some microbes have been discovered that can break down certain types of plastic, using them as a source of energy. These organisms, thriving in the most unlikely places, remind us of nature's endless capacity to respond, even to what seems like pollution beyond repair. Still, the image lingers. The darkest places on Earth, long thought beyond human touch, now marked by threads of synthetic waste. As we drift deeper into the story of the seas, the realization settles that we are not only discovering the mysteries of the ocean, we are also uncovering our own reflection in it, a reflection scattered in fragments of plastic that now belong to the fabric of the deep. And from here, the narrative of the ocean turns once again to the grand forces that shape the planet, currents that stir climate and connect continents, threads of water that carry warmth and life across the globe. Beneath the restless surface of the sea, Hidden from casual view, a slow and powerful current moves water around the globe. It is often called the ocean conveyor belt, a name that captures both its steadiness and its importance. Unlike the waves we see or the tides that rise and fall each day, this conveyor moves on timescales of centuries, carrying heat, salt, and nutrients across vast distances. It connects every ocean basin into one global system, linking the tropics to the poles and the surface to the abyss. The journey begins in the warm waters near the equator. Sunlight heats these regions, and winds push the surface waters in steady directions, creating currents like the Gulf Stream. This ribbon of warm water flows northward along the coast of North America, carrying heat into the Atlantic. As it travels, it releases warmth into the air, softening winters in Europe and shaping weather patterns across continents. Without it, much of the northern hemisphere would be locked in harsher cold. Farther north, in places like the Labrador and Nordic seas, the story changes. Here, the warm surface waters cool, and their salinity increases as ice forms and leaves salt behind. The water becomes heavy, so dense that it sinks to the deep. This sinking creates one of the engines that drives the conveyor, pulling more warm water northward while pushing cold water into the abyss. The deep currents then flow south, carrying chill and nutrients toward the Southern Ocean, where they circle Antarctica and split into paths that eventually return upward in distant parts of the Pacific and Indian Oceans. The conveyor belt is not only about temperature, it is also the reason the deep ocean is supplied with oxygen and the surface with nutrients. As waters sink, they carry dissolved oxygen from the atmosphere into the deep. As waters rise again, they bring with them the remains of countless organisms that have fallen from the surface, delivering nutrients to fuel new life. In this way, the conveyor stitches together the ocean into one continuous cycle of renewal. But this elegant system is fragile. Climate change threatens to disrupt the balance that keeps it moving. As glaciers and ice sheets melt in Greenland and Antarctica, they release vast amounts of fresh water into the sea. Fresh water is lighter than salty water, and when too much of it enters the northern seas, it dilutes the saltiness that makes the water heavy enough to sink. If the sinking slows, the entire conveyor can weaken. Already, studies suggest that the Atlantic portion of this system is slowing down, perhaps at its weakest point in more than 1,000 years. The consequences of such disruption would reach far beyond the ocean. Weather systems on land are tied to the movements of the sea. A weakened Gulf Stream could mean harsher winters in parts of Europe, stronger hurricanes in the Atlantic, and shifting monsoons that billions of people depend on for water and food. In South America and Africa, rainfall patterns could change, threatening agriculture. Even the vast Amazon rainforest, one of the lungs of the planet, is linked to moisture carried by the ocean conveyor. Understanding these currents is one of the great challenges of modern science. Satellites can trace surface waters and measure temperatures, but the deep parts of the conveyor remain almost invisible. Sensors lowered into the abyss provide only snapshots, scattered across years. The scale is immense, the forces subtle, and the timescales so long that no human lifetime can see the full cycle. We map the stars with greater clarity than we trace these slow rivers of the deep. Yet their importance is undeniable. They are the hidden architecture of climate, the silent threads that bind weather, ecosystems, and life itself into one connected web. And as we drift deeper into this story, the currents that shape climates lead us toward other hidden realms, frozen frontiers where oceans themselves are sealed beneath ice, waiting to be uncovered. At the edges of our planet lie realms where the ocean meets ice, frozen frontiers that feel more alien than earthly. The polar seas, wrapped in cold and silence, stretch beneath skies of pale light and endless night. Their surfaces are locked in drifting sheets of ice, but beneath, life continues in hidden waters that remain some of the least explored on Earth. These are places both fragile and immense, where the line between sea and land blurs into frozen landscapes that defy easy description. Antarctica is the heart of this mystery. Beneath its thick ice sheets, some more than 4 kilometers deep, lie buried lakes sealed away from the atmosphere for millions of years. One of the most remarkable is Lake Vostok. Larger than Lake Ontario, it rests beneath a vault of ice that has kept it isolated since long before humans walked the earth. Its waters have never felt the touch of wind or sunlight. The pressure from the ice above keeps it liquid, and geothermal heat from Earth's interior adds a faint warmth. Within this hidden world, scientists believe entirely unique ecosystems could exist, microbial life that has adapted to conditions unlike any we know. To touch it, however, is a delicate challenge. Drilling through kilometers of ice risks contamination, and so Lake Vostok remains a place glimpsed only through samples of frozen water pulled up in cores, whispers of a vast, living body still untouched. The ocean surrounding Antarctica tells its own story. Here, the Southern Ocean circles the continent in a current so powerful it connects all other oceans together. It is the only current that flows around the entire planet, unbroken by land, and it acts as a highway for nutrients and life. The waters here are cold, dense, and rich with oxygen, sinking into the abyss and feeding the conveyor belt that regulates global climate. The creatures that live in these waters are shaped by extremes. Colossal squid hunt in the deep, penguins dive into freezing surf, tiny krill swarm in numbers so vast that they are considered one of the most important species on Earth, supporting whales, seals, and countless fish. Without the polar seas, the rhythms of the entire ocean would falter. The Arctic, though smaller, is no less captivating. Here, sea ice grows and shrinks with the seasons, covering millions of square kilometers in winter and retreating in summer. The ice is more than frozen water. It is a habitat, sheltering algae and plankton that cling to its underside, forming the foundation of entire food webs. Polar bears hunt along its edges, seals breathe through its cracks, and narwhals and belugas navigate its shifting labyrinth. Beneath the ice, the Arctic Ocean holds basins and ridges that are still scarcely mapped, regions so remote that only a handful of scientific expeditions have touched them. The fragility of this region is profound. Warming temperatures melt the ice earlier each year, thinning the cover that has defined the Arctic for millennia. As the ice retreats, the balance of life that depends on it is shaken. Exploring these frozen seas is among the hardest tasks science has ever attempted. Machines must endure crushing cold, shifting ice, and isolation that stretches for months. Submarines risk entrapment under ice sheets, instruments freeze, batteries die, and storms cut off communication. Even satellites struggle to see through the white expanses, their signals scattered by snow and cloud. The result is that much of what we know of the polar oceans comes from fragments of data, pieced together like glimpses through fog. What we have found is astonishing, yet it is clear that we have only skimmed the surface. And while Antarctica's buried lakes and the Arctic's drifting ice fields still resist our full attention, they remind us of something profound. These frozen frontiers are not empty wastelands. They are living laboratories, places where Earth's secrets are stored in silence. Locked beneath the ice are histories of climate stretching back millions of years, preserved in layers of snow that record every storm every shift of temperature, every breath of carbon dioxide. Locked within the waters are life forms that may show us how survival endures in the harshest places, and perhaps even how life might exist on distant frozen moons. From here, the story of the ocean flows outward once again toward the smallest of creatures in the deep, microbes that thrive where light and warmth cannot reach, carrying us into an unseen kingdom that reshapes our understanding of what life can be. Far below the waves, in a realm that seems inhospitable to any form of life, there exists a hidden kingdom. It is not ruled by whales or giant squids, nor by the fish and corals we can see with our own eyes. This kingdom belongs to the smallest of all inhabitants, tiny microbes that flourish in places once thought too extreme for anything to survive. Their world is measured not in forests or reefs, but in single cells that cling to stone, drift in the currents, or thrive in chemical clouds that rise from the seafloor. At hydrothermal vents where black smoke pours into the water, temperatures can climb to more than 300 degrees Celsius. Here, instead of dying in the scalding heat, microbes have learned to make these vents their homes. They feast not on sunlight, which cannot reach this deep, but on chemicals pouring from Earth's interior. Hydrogen sulfide, toxic to most forms of life, becomes their fuel. From these chemical reactions, entire communities are built. Tube worms, clams, and shrimp gather around the vents, living in partnership with the microbes that transform poison into energy. What begins as invisible life becomes the foundation for ecosystems as rich as tropical forests, all in the absence of sunlight. Elsewhere in the ocean, the seafloor seeps with methane, a gas trapped in sediments that slowly bubbles upward. To most creatures, methane is no source of nourishment, yet microbes have evolved to use it as their energy supply. In doing so, they create oases of life where otherwise there would be only barren mud. Mussels and other animals grow in these places, depending on their microbial partners. This ability to turn gas into food shows a creativity of life that stretches far beyond our ordinary understanding. Some microbes go further still, consuming substances that seem almost unimaginable as food. There are bacteria that eat oil, breaking down slicks that spill into the sea. Others have been found clinging to metal, slowly drawing energy from iron and manganese. Some are capable of digesting plastics, an adaptation so recent and so surprising that scientists believe these microbes are evolving in response to human pollution. In every corner of the ocean, no matter how inhospitable, it seems there is a form of life willing to adapt and endure. The importance of these microbial kingdoms is greater than their size suggests. They not only survive in extremes, but shape the chemistry of the entire ocean. They recycle nutrients, filter toxins, and even influence the gases that rise into the atmosphere. Without them, the balance of the planet would falter. Yet we have studied only the faintest fraction of them. Each expedition into the deep brings up samples of microbes no one has ever seen before. Many cannot be grown in laboratories, vanishing when removed from their dark and pressurized homes. The mystery of their existence remains tied to the abyss. What makes these microbes even more remarkable is their potential. Some produce compounds that could serve as antibiotics or cancer treatments. Others generate enzymes that may help us break down plastic waste or harvest new sources of renewable energy. In their tiny bodies, there may be keys to solving some of humanity's greatest challenges. But there is another side as well. Microbes can also carry dangers. Some thrive on toxins that might be harmful if unleashed, and others could alter environments in ways we do not yet understand. The deep sea holds both promise and risk, and within its microbial kingdoms lie secrets we are only beginning to uncover. The story of these microbes reminds us that life's imagination is greater than our own. While we search the skies for signs of biology on other planets, entire worlds of microscopic wonder thrive beneath our feet, waiting in the dark. And from these hidden realms, the ocean leads us into deeper questions, where history itself is preserved in the shifting sands and sediments of the sea, holding memories of Earth that stretch back to the beginning of time. The ocean does not only hide unknown creatures and landscapes, it also holds the forgotten stories of our own kind. Beneath its waves lie relics of human history, sealed away in silence for centuries, sometimes for millennia. Thousands of shipwrecks rest on the seafloor, their wooden frames and iron hulls slowly consumed by salt and time. Some carried treasure, others carried lives, and all of them carried stories. Every wreck is a frozen moment, a sudden pause in the flow of human ambition. In the Mediterranean, the sea conceals galleys of ancient empires, Roman vessels that once carried wine, olive oil, and marble across trade routes that bound nations together. Amphorae still lie scattered across the seabed, amphorae that once held the goods of everyday life. Their curved shapes are as familiar as pottery dug from land, yet their resting place is the deep, where they have remained untouched since the day storms or battles pulled them under. Further north, off the coast of Scandinavia, ships of Viking raiders have been found, wooden planks preserved by cold waters. These vessels, with their carved prows and sails of woven wool, once sliced across the seas with fury. Now they lie quietly in darkness, reminders of a time when human courage was bound to fragile wooden frames. Each plank is a testament to how far people were willing to go, guided only by stars and the strength of their oars. The number of wrecks is staggering. Historians estimate there may be more than 3 million still resting beneath the oceans worldwide. They range from the mighty warships of the Spanish Armada to the merchant ships lost to storms in the Indian Ocean. They tell stories of conquest, of trade, of hope, and of loss. With every expedition, divers and submersibles bring new discoveries. Bronze cannons, porcelain bowls, coins stamped with forgotten empires, and even perfectly preserved clothing emerge from their watery graves. These objects are not only artifacts, they are fragments of lives lived long ago. It is not only ships that rest beneath the surface. Entire cities have been claimed by the sea. Off the coast of Greece lies Pavlopetri, the oldest known submerged city, dating back more than 5,000 years. Streets, courtyards, and building foundations are still visible, carved into the seafloor. Here, people once walked, traded, and raised families. Rising seas and shifting earth pulled it under, turning a living community into a hidden time capsule. Other cities have suffered the same fate. Heracleion, a great port of ancient Egypt, was swallowed by the Mediterranean more than 1,000 years ago. Divers have uncovered colossal statues of gods and pharaohs, toppled and resting in silt. Great stone temples that once welcomed ships now stand tilted and broken, their outlines blurred by sand. Coins and jewelry are found scattered among their ruins, everyday objects left behind in a sudden catastrophe. These underwater ruins blur the line between myth and reality. Cities once whispered of in legend are slowly being revealed, not by storytellers, but by divers armed with lights and cameras. The preservation of these sites is extraordinary. Sunlight never touches the deeper ruins, and oxygen struggles to reach them, which slows the march of decay. Fabrics, scrolls, and even food have been discovered preserved in sealed jars. Each dive is a meeting with a forgotten past, as if the ocean has been holding its breath for centuries, waiting for us to return. The ocean's lost history reminds us that the sea is not only a wilderness of unknown life, it is also a library of human memory. Every wreck, every sunken street, and every artifact is a page of a book too vast for us to ever finish. Yet with each dive, another fragment is brought back into light, another story recovered from silence. And as we peer at these remnants of ourselves, the ocean continues to hold secrets still deeper, secrets that drift far beyond the reach of human history, hidden in the black labyrinths beneath the waves. The surface of the ocean feels vast, yet familiar. Waves crash, tides shift, and ships sail across it. But beneath, hidden in shadows, are places that make even seasoned explorers pause. Among the most dangerous and least understood are submarine caves, vast labyrinths carved into the rock by water over millions of years. These hidden passages wind and twist, forming a black maze that stretches beneath coastlines, coral reefs, and continental shelves. Unlike open water, where there is at least the chance of escape, a cave is an unforgiving trap. Once inside, there is only one way out, and the path is often more treacherous than the way in. Divers who have entered these submerged caverns describe them as unlike anything else on Earth. The moment a beam of light cuts across the walls, the space reveals formations sculpted over time. Stalactites hang where they once grew in air, proof that many of these caves were dry thousands of years ago, during ice ages when sea levels were lower. As the seas rose, the caves filled, sealing away a frozen record of past climates and ancient landscapes. In some places, bones of extinct animals have been discovered, preserved in the cool, oxygen-poor water. These caves are not just geological features, they are time capsules holding evidence of Earth as it once was. But beauty is paired with danger. Submarine caves are considered by many to be more perilous than spacewalks. In space, an astronaut has a tether, communication, and a clear view of the stars. In a cave, a diver has only a line leading back, and the walls close in with suffocating silence. The risk is immense. Equipment failures or even a wrong turn can be fatal. There is no surface to break through for air, only rock and water stretching endlessly. Many divers have lost their lives in these places, and their stories echo through the diving community as warnings of the unforgiving nature of the Black Labyrinth. Mapping such spaces is nearly impossible. Unlike the open ocean, which can be scanned with sonar or satellites, these caves offer no clear geometry. Some passages are so narrow that only a single diver can squeeze through. Others open into chambers so large they feel like underwater cathedrals, their ceilings disappearing into darkness. And still deeper, some passages end abruptly in walls, while others plunge vertically into shafts with no bottom in sight. The complexity of the networks means that no two caves are ever the same, and many remain entirely unmapped. Explorers rely on spools of guiding rope to mark their way back, a fragile lifeline in the face of a vast, twisting maze. In regions like the Yucatan Peninsula, underwater caves called cenotes stretch for hundreds of kilometers beneath the limestone. Divers there have found human remains from ancient civilizations, offerings left in sacred rituals. These discoveries remind us that caves are not only natural wonders, but also places of human history and myth. In other parts of the world, such as the Bahamas, vast blue holes descend straight down, their depths concealing toxic layers of water where life struggles to survive. Each cave system tells a different story, and each is a challenge to understand. Science has only begun to scratch the surface of what these environments hold. Strange species of blind fish, pale shrimp, and translucent eels live inside, adapted to life without sunlight. Some of them are found nowhere else on Earth. In these eternal shadows, evolution has followed unique paths, creating life forms that show us how resilient and inventive biology can be when faced with impossible conditions. Exploring submarine caves is like walking into Earth's hidden lungs. They breathe in silence, holding secrets that stretch back into prehistory, yet they allow only the smallest glimpse before reminding us of their dangers. Even with modern technology, rebreathers, and powerful lights, these caves remain a realm of mystery. They are the black labyrinths of the sea, unforgiving, beautiful, and almost unknowable, each passage a reminder of how little of this planet we have truly seen. Beneath the rolling waves, in places where the sun's rays cannot reach, live creatures that seem as though they were dreamed up in the fevered imagination of myth. Yet they are not myths, nor the inventions of storytellers, but real animals that evolution has shaped in ways so extraordinary they often defy belief. In the twilight and abyssal depths of the sea, life has found paths that look nothing like the creatures of the shallows or the familiar animals of land. These beings remind us that the rules of survival can be bent and twisted into forms that feel both alien and strangely elegant. Among the most haunting is the goblin shark, sometimes called a living fossil because its lineage stretches back tens of millions of years. With a long, flattened snout and a jaw that can suddenly launch forward like a trap, it is unlike any other shark on Earth. Its teeth, thin and nail-like, are built for gripping slippery prey in the dark. In photographs, its pinkish skin and ghostly eyes make it look unreal, as though it belongs more to a nightmare than to the sea. Yet it is a quiet predator, cruising in the shadows at depths too dark for human eyes, a creature designed perfectly for a world where stealth and surprise are the key to survival. Deeper still drifts the vampire squid, whose very name sounds born of horror. But in truth, it is a gentle scavenger, feeding not on blood, but on falling marine snow, the constant drizzle of organic matter sinking from the surface. Its body is draped in a cloak-like web that stretches between its arms, and when threatened, it can turn itself inside out, displaying spiny filaments that look far more fearsome than they are. Its skin glows with bioluminescence, tiny lights that flicker like stars in the abyss. Far from being a terror of the deep, the vampire squid is a marvel of efficiency, adapted to thrive in places with so little oxygen that most animals would suffocate. Then there is the anglerfish, one of the deep ocean's most iconic predators. The female carries a lantern, a glowing lure that dangles from her head and draws prey toward her gaping mouth. Her teeth curve inward like hooks, ensuring that once something enters, it cannot escape. In the crushing black of the abyss, she waits motionless, a light in the void, until an unsuspecting fish wanders too close. Perhaps even stranger is her reproductive strategy. Males are tiny compared to females, so small they seem like a different species. When a male finds a female, he fuses to her body, his organs shrinking away until he is little more than a source of sperm permanently attached. This bizarre arrangement ensures that in the vast emptiness of the deep, where encounters are rare, reproduction is still possible. These are only a few of the ocean's most surreal inhabitants, yet even they represent only the surface of possibility. In the darkness, where pressures would crush human-built submarines, evolution has written countless other stories. Some fish have transparent heads through which their eyes peer upward, scanning for silhouettes of prey above. Others have jaws that open wider than their entire bodies, allowing them to swallow meals larger than themselves in a single strike. There are creatures with bodies so gelatinous they collapse when brought to the surface, beings that cannot even be studied outside of their native depths because the delicate balance of pressure and temperature that keeps them alive cannot be recreated in a laboratory. Every remotely operated vehicle that descends into the deep seems to encounter something never catalogued before. Sometimes it is a new species of jellyfish, pulsing through the dark with colors that shimmer like stained glass. Sometimes it is a worm that glows in shifting patterns of blue and green. Each discovery is a reminder that the ocean, vast and secretive, holds forms of life we have not even begun to imagine. For every goblin shark or anglerfish we know, there may be dozens more hidden in trenches, ridges, and unexplored canyons. The strangest part is how these animals, as alien as they seem, are not monsters. They are not accidents. They are solutions. Each one represents an answer to the same fundamental question. How do you survive in a place where there is no light, where food is scarce, and where the environment seems determined to crush you at every moment? The adaptations they reveal are not simply curiosities. They are blueprints for resilience, evidence that life is not confined to narrow rules. It bends, it shifts, it invents entirely new ways of being. As researchers continue to peer into these black waters, every new image and every new sample stretches the boundaries of what we thought was possible. The creatures of the abyss are not just marvels of biology, they are hints of what might exist elsewhere in the universe. If such strangeness can thrive here, on our own planet, then the possibilities for life in other hidden oceans, beneath the ice of distant moons, become even more real. Far below the rolling waves, where the seafloor stretches for thousands of miles, lie mysteries that science has not yet unraveled. The ocean is vast enough to swallow continents and deep enough to hide worlds within worlds, and in that immensity, it guards secrets that slip through even our most advanced instruments. Sonar sends out pulses that echo against the seafloor, mapping the unseen, yet sometimes those echoes return with shapes and signals that defy explanation. Strange contacts appear on monitors, too large to be dismissed as whales, too irregular to be geological ridges, yet when ships or remotely operated vehicles are sent to investigate, the signals vanish as though whatever produced them simply dissolved into the water. For decades, researchers and naval crews alike have reported these anomalies, cataloged them, and puzzled over their meaning. Some may be echoes distorted by temperature layers in the water, others may be migrations of little-known species, but many remain unanswered questions, their true origins hidden in the silence of the deep. The ocean has always been a place where things disappear. Ships built of steel and guided by satellites still vanish without a trace, their last known positions swallowed by storm or current. Some may founder in rogue waves, towering walls of water that rise without warning and leave no survivors to tell the tale. Others may be pulled down by hidden reefs or seafloor ridges, mapped only in fragments. And then there are those cases where no cause is ever found, where ships vanish on calm days with no distress calls sent. The ocean leaves little evidence, scattering wreckage across miles or burying it under sediments within hours. Even in an age of global tracking, mysteries persist, reminding us that this vast water planet is not fully tamed by technology. Beneath the waves are not only lost ships, but landscapes that challenge our understanding of Earth itself. On the sea floor, scattered across thousands of miles, rise formations that look like vast geometric ridges, spirals, or concentric patterns etched into stone. Some may be the work of ancient volcanic processes, cooled into shapes we barely recognize. Others may be built from minerals that accumulate in ways unfamiliar on land. And sometimes, As in the case of the Baltic Sea anomaly or other unusual sonar images, the shapes appear too regular, too precise, as though they were carved by design rather than accident. Oceanographers remain cautious, knowing how easily sonar can distort and how often the sea shapes rock into unfamiliar patterns. Yet each new anomaly keeps alive the sense that the seafloor still holds geological features with origins beyond what we can currently explain. There are also the strange sounds that drift across hydrophones, recorded but never identified. Low rumbles that last for minutes, pulses that travel across entire oceans, even clicks and calls that do not match any known animal. Some of these signals may tie into sonar anomalies, others may be linked to shifting tectonic plates or submarine volcanoes, yet in many cases, no firm explanation has ever been found. Scientists catalog them with names like the Bloop or Julia, little reminders of how much remains hidden in the soundscape of the ocean. Even in places where human exploration has gone deepest, like the Mariana Trench, discoveries raise more questions than answers. Ridges that rise unexpectedly, sediments that flow like rivers at the bottom of the sea, and glowing organisms that appear briefly in camera lights only to vanish again. For every answer gained by exploration, a dozen new mysteries emerge, each one widening the gap between what we know and what we suspect. The ocean is not only a cradle of life, but also a vast and restless archive of enigmas, sonar contacts that vanish, ships that slip silently into oblivion, geological structures that seem almost otherworldly, and sounds that echo with no clear source, all remind us that our planet still contains regions where mystery reigns. The next chapter of discovery does not lie only in solving these puzzles, but also in accepting that the ocean will always keep some of its secrets beyond our reach, even as we press further into the deep. For all the brilliance of modern science, for all the rockets we have sent into orbit and the probes we have flung toward the edges of the solar system, our ability to explore the ocean remains astonishingly limited. The technology we have, powerful as it may seem, struggles against the sheer scale and hostility of the deep. Even the most advanced machines falter when faced with the crushing pressures, the vast distances, and the unforgiving nature of the sea. Human-occupied submarines are perhaps the most iconic tools we possess for visiting the depths. They are marvels of engineering, shaped like capsules and wrapped in walls of steel or titanium, thicker than the vaults that guard our greatest treasures. Yet their strength comes at a steep cost. Each descent is expensive, requiring vast amounts of preparation, specialized crews, and vessels to carry them out to sea. A single dive may last only a few hours, after months or even years of planning. These submarines can only descend a handful of times before requiring major maintenance, and there are only a few in the world capable of reaching the deepest trenches. As a result, manned exploration of the ocean is rare, a privilege reserved for only the most determined scientists or occasional adventurers willing to risk it all for a glimpse of the abyss. To extend our reach, remotely operated vehicles, or ROVs, are often sent where humans cannot go. They glide through the dark, tethered to ships on the surface by thick cables that provide power and communication. Their cameras capture haunting images of landscapes never before seen. Their robotic arms grasp samples from vents and trenches. Yet they, too, are fragile, constantly threatened by the very environment they are built to withstand. The cables can snap under stress, the machinery can be crushed or clogged by sediments, and the intense pressure can warp even carefully designed housings. Each ROV is costly to build and operate, and many have been lost to the depths, vanishing into places where no recovery is possible. Their endurance is short, their missions fleeting, leaving the ocean still largely untouched. Satellites, which have revolutionized our understanding of space, face a wall when confronted with water. Their sensors can map the outlines of continents, track currents, and even measure slight changes in sea surface height that hint at mountains and trenches far below. But they cannot pierce the depths themselves. Light and radio waves scatter and vanish within only a few meters of water, leaving the vast interior of the ocean invisible to their gaze. At best, satellites give us shadows, blurred impressions of what lies beneath, never the clear detail they provide of distant planets and stars. This limitation makes the contrast between ocean exploration and space exploration even sharper. Telescopes can peer across billions of light years, drawing detailed portraits of galaxies that existed long before Earth was born. Yet sonar, our primary tool for probing the seafloor, struggles to penetrate more than a few kilometers with clarity. The deeper we try to look, the blurrier the picture becomes. Mapping the ocean in detail would take centuries with current technology, and even then, the ever-shifting nature of the sea means no map would remain truly complete. The scale of the ocean is its greatest defense against our attempts to understand it. Every piece of technology, from submarines to ROVs to satellites, faces limitations that make the dream of fully exploring the sea seem almost impossible. For now, what we have is a collection of fragments, rare dives into trenches, fleeting glimpses from fragile robots, faint outlines captured by satellites far above. Each fragment adds to the picture, yet the picture will always remain incomplete. And so the ocean holds its mysteries, not only because it is vast and hostile, but also because our machines, brilliant as they are, cannot yet match the scale of its immensity. The sea reminds us that while we may reach for the stars, we are still humbled by the depths of our own world. The ocean is not only deep and mysterious, it is vast beyond comprehension. When scientists speak of its scale, the numbers feel almost impossible to imagine. The volume of Earth's oceans is estimated at more than 350 quintillion gallons of water, a number so large it stretches beyond what the human mind can comfortably hold. To place it in perspective, if every person alive today tried to count each gallon one by one, working every second without rest, the task would last longer than all of recorded history. The sea is not just wide, it is immeasurable in its immensity, a body of water so expansive that our attempts to fully explore it become almost absurd when compared to its true size. Exploration depends on tools, but those tools must operate within limits of time and energy. Sonar waves can scan the seafloor, sending back echoes that sketch outlines of ridges and trenches, but every scan covers only a small patch of water. Ships towing sonar equipment creep slowly across the surface, their beams reaching downward to build a picture of what lies beneath. If we attempted to scan every stretch of the ocean in this way, working without pause, the task would not be finished for thousands upon thousands of years. And by the time the last patch of seafloor was mapped, the first maps would already be outdated as currents shift sediments, volcanoes reshape ridges, and new fissures open in the planet's restless crust. Even satellites, which give us broad glimpses of the ocean's shape, cannot bypass the scale problem. They can detect slight variations in the height of the sea's surface, revealing the gravity of seamounts and trenches far below, but the details remain blurred, like shadows seen through fog. To sharpen those shadows into true images requires close work, and close work takes time. A single research expedition may return with incredible discoveries, but in the context of the whole ocean, it is like studying a single drop of rain to understand an entire storm. This immensity has consequences not only for mapping, but for discovery. Each remotely operated vehicle that descends into the dark waters explores only a tiny cone of space, a narrow slice of the abyss. Even if thousands of such dives were carried out, they would barely scratch the surface of the deep. Every time a new creature is filmed or a strange landscape comes into view, it is accompanied by the awareness that there are countless more waiting, hidden in the endless expanse that has never been touched by light or lens. The ocean is in constant motion, its waters cycling in patterns that span centuries. Currents weave and twist, carrying heat, nutrients, and even life across entire basins. A gallon of seawater drawn from the surface may not return to the same place for hundreds of years as it travels through this global conveyor of circulation. In that time, conditions change, species adapt or vanish, and seafloors shift. Exploration becomes not only a matter of distance but of time, as the object of study evolves before it can be fully known. To call the task mathematically impossible is not an exaggeration. Imagine an army of scanning ships, each one sending out sonar day and night. Imagine fleets of robotic submarines drifting through every depth. Even then, the sheer volume of water would defeat them, a reminder that the ocean is not a laboratory that can be neatly catalogued, but a living system so immense that its secrets will always outpace our reach. And perhaps this is part of the ocean's enduring power. Its scale ensures that it will never be fully grasped. It allows mystery to endure in a world where so much else has been mapped, charted, and cataloged. Even as our machines grow more sophisticated, the numbers remain immovable, and the ocean continues to remind us that some frontiers are simply too vast to conquer. When we look at where humanity chooses to spend its resources, the imbalance is striking. Each year, billions upon billions of dollars flow into the exploration of space. Rockets climb into the sky with cameras and instruments, satellites are launched in fleets, and ambitious plans are drawn for Mars and beyond. In contrast, the oceans, which cover more than 70% of our planet and hold the greatest share of its mysteries, receive only scraps by comparison. The budgets are thin, the research vessels few, and the teams that dedicate their lives to studying the sea often must fight simply to secure enough funding for a single expedition. This disparity does not come from lack of importance. The oceans regulate Earth's climate, feed billions of people, and hold untold potential in medicines, minerals, and energy sources. Yet politically, the ocean floor lacks the glamour of the heavens above. Space has always carried with it a sense of drama, the promise of new worlds and civilizations, the symbolic achievement of reaching beyond our home. The sea, though equally alien and mysterious, remains hidden in darkness and silence, far away from the eyes of those who make decisions. It does not dazzle in the same way a rocket launch does, and because of this, the urgency to explore it is far weaker. Ocean science is often forced into narrow windows of opportunity. A research team may wait years for the chance to take a ship out to sea, and when that time comes, every hour counts. Voyages must be carefully planned, as funding rarely allows for repeated journeys. The instruments they bring are expensive to maintain, and if one fails under the crushing pressure of the depths, it may never be replaced. Even the construction of specialized submarines or remotely operated vehicles often requires private donors or partnerships with industries such as oil and gas, which have their own interests in exploration. This dependence means pure scientific curiosity is often set aside in favor of economic utility. The imbalance is especially evident when we consider the sheer difference in scale. Space programs are equipped with immense facilities, vast teams of engineers, and steady streams of funding that allow continuous innovation. Oceanography, in many parts of the world, operates with fleets of ships that are decades old, instruments that are patched together from limited supplies, and researchers who spend as much time writing grant proposals as they do conducting science. The potential is extraordinary, but the means to unlock it remain frustratingly out of reach. The irony is that discoveries from the deep could have immediate impacts on our lives. Microbes that live in vents under the sea may hold the key to new antibiotics. Fish populations, if better understood, could be managed to ensure food security for generations. Ocean currents, if mapped with precision, could sharpen our understanding of climate and allow better predictions of storms and droughts. Yet without adequate investment, these insights come slowly, in fragments, leaving us less prepared for the changes unfolding in the present. There are scientists who speak of a blue space race, a vision where exploration of the oceans is given the same urgency as exploration of the skies, yet such dreams remain distant. Governments hesitate, private investors favor ventures with quicker returns, and the public often remains unaware of how much is left undiscovered beneath the waves. The sea continues to wait patiently, as it has for millions of years, while our attention turns elsewhere. And so the pattern continues, rockets soaring, while research ships drift in obscurity, telescopes gazing at distant galaxies, while sonar equipment struggles to map trenches a few miles from shore. The imbalance is not a reflection of importance, but of perception, of where human imagination prefers to wander. This lack of focus ensures that much of the ocean will remain uncharted, not because it is unreachable, but because the will to explore it has never matched its true value. Every time humanity attempts to explore the deep, it is a step into an environment that resists us at every turn. The ocean is not passive, it presses back with forces that strain both body and machine. It is a realm where every degree of temperature, every ton of pressure, and every mile of distance adds to the risk. Exploration is not just a matter of curiosity, it is a gamble, and each descent into the deep carries the weight of that gamble. Cold is among the first and most constant hazards. The deeper we descend, the further we leave behind the warmth of the sunlit surface. Temperatures fall steadily until they hover just above freezing, a chill so profound it seeps through steel and titanium, testing the limits of insulation. For human divers, even in suits designed for protection, such cold can bring numbness and fatigue. For machines, it slows chemical reactions in batteries, stiffens lubricants, and makes materials brittle. The deep ocean does not need to attack directly. Its cold alone can weaken and break what enters it. Pressure, though, is the more brutal adversary. With each 10 meters of descent, the weight of the water above increases. By the time a craft sinks 1,000 meters, the force pressing on its walls is already 100 times greater than what we feel at the surface. At the depth of the deepest trenches, that pressure multiplies more than 1,000-fold. To resist it, submarines must be built like fortresses, their walls thicker than bank vaults, their shapes rounded to distribute stress evenly. Yet even with such design, the margin for error is vanishingly small. A crack, no wider than a hair, can lead to catastrophic collapse. Machines, no matter how strong, carry this constant risk, and for humans sealed inside, the awareness of it never disappears. Isolation deepens the danger. Once an expedition leaves the surface, it enters a space where communication is limited and slow. Radio waves cannot pass through water, so the tools of connection that guide astronauts or aircraft pilots vanish. Messages must travel as sound through the sea, delayed and distorted, or along long cables that tether fragile vehicles to their ships above. If something goes wrong, help cannot simply arrive in minutes. A stranded diver or a disabled machine is cut off, far below the reach of rescue. This isolation is part of what makes each descent so sobering. Those who go down know that the sea grants no second chances. For divers themselves, the risks are amplified by biology. Human lungs are not built for pressure. Our tissues respond unpredictably to gases when compressed. Too much nitrogen can intoxicate the brain, leading to confusion and poor judgment. Oxygen, in high concentrations, can itself become toxic. Even rising back to the surface too quickly carries danger as gases expand within the body, forming bubbles that can cripple or kill. Specialized techniques and equipment extend the limits of human endurance, but those limits remain narrow. Most of the deep remains utterly inaccessible to the human body. Machines are meant to expand those limits, but they too falter. Cables snap, propellers jam with silt, cameras shatter under pressure, and electronics corrode in the salt water. Sometimes entire vehicles vanish, sinking silently into the abyss with no chance of retrieval. Every mission carries the possibility of loss, whether of expensive equipment, priceless data, or in rare and tragic cases, human lives. Yet explorers return to the sea again and again, drawn by the promise of what lies unseen. The hazards never vanish, but each successful dive shows a glimpse of what waits in the dark. Cold, pressure, and isolation make the deep ocean a hostile frontier, but they also make it one of the most humbling, reminding us that discovery often comes at the edge of what we can endure. The ocean does more than cover the surface of our planet. In many ways, it acts as a memory, an archive written not in books or digital code, but in the quiet layering of sediments that sink slowly through the water. Every grain of sand, every particle of dust, every shell of a tiny creature that falls from above eventually settles on the seafloor. Over time, these fragments compress into thin layers, one resting on top of another, forming pages in a vast geological diary. Within these layers lies the story of Earth itself, a record of shifting climates, of mass extinctions, of species that flourished and vanished, and of the forces that have shaped our planet across millions of years. When scientists take core samples from the deep, they are in effect pulling out time capsules. A single tube of mud may hold hundreds of thousands of years of history, each centimeter representing centuries of change. In those fine bands of sediment, trapped in chemical traces and microscopic fossils, are clues about temperatures, rainfall, and even the composition of the atmosphere at the time they were deposited. In some layers, scientists find the telltale signs of catastrophe, such as the sudden spike of iridium that marks the asteroid impact which ended the reign of the dinosaurs. In others, they see the gradual fluctuations of ice ages recorded in the shells of plankton that reflect the chemistry of the seas in which they lived. But accessing this memory is far from easy. The deep seafloor is not a bookshelf waiting to be opened. It is a fragile environment, delicate and easily disturbed. The very act of lowering equipment can scatter sediments, erasing the fine details scientists hope to preserve. Vehicles that land on the seabed can crush habitats of organisms that have lived undisturbed for centuries. Even drilling carefully risks mixing layers together, blurring the sequence of events that nature wrote so patiently over eons. The challenge is not only reaching the seafloor, but doing so in a way that leaves its record intact. The difficulty of reading these ocean archives is compounded by their vastness. Sediments are not uniform. They change with depth, with distance from shore, and with the rise and fall of ocean currents. One core might tell the story of a volcanic eruption that darkened skies thousands of years ago, while another, taken a few hundred miles away, might reveal the slow accumulation of nutrients that supported blooms of life. To piece together a global picture requires countless samples drawn from scattered points across a seabed that stretches for more than 200 million square miles. It is a puzzle so immense that even the most dedicated teams can only assemble fragments. Within those fragments, however, are extraordinary discoveries. Deep layers of mud have revealed cycles of warming and cooling long before human history began, showing how delicate the balance of Earth's climate has always been. Others have uncovered evidence of ancient tsunamis, their force captured in sudden deposits of sand carried far offshore. In some places, sediments hold the remains of organisms so small they can only be seen under a microscope, yet in their shells and chemical signatures lies information about oceans that existed tens of millions of years ago. These records stretch further back in time than any human document, further than the oldest cave painting or clay tablet, offering insights into a world we never saw. And while these archives are precious to science, they are also vulnerable. Human activity, from deep-sea trawling to mining, threatens to disturb sediments on a scale never seen before. What took millions of years to record can be erased in moments by the drag of machinery across the seafloor. This risk casts a shadow over exploration, raising questions about how much of the ocean's memory we may lose before we have even begun to read it. Still, the ocean continues to write its story, day after day. Dust carried by winds settles into it, volcanic ash falls from distant eruptions, shells drift slowly downward, and the remains of life sink to join the record. Layer upon layer builds, creating a living memory that grows deeper with every passing century. It waits quietly, patient and vast, preserving the tale of Earth in ways we are only just beginning to understand, while we push forward into the next chapter of discovery. For as long as people have gazed out across the sea, there has been a longing to know what lies beneath. The ocean has always been a place of imagination, filled with both fear and wonder. Yet for most of history, it was an unreachable frontier. The idea of traveling to its greatest depths seemed as impossible as touching the stars. But in the 20th century, bold attempts were made to break that barrier, to send humans into the abyss and see what secrets it might reveal. One of the earliest and most iconic of these attempts came in the year 1960, when a vessel called the Trieste descended into the Mariana Trench. This trench, hidden in the western Pacific, is the deepest known place on Earth, and the Trieste carried 2 men to its floor. The craft was not sleek like a submarine, but shaped like a bathyscaphe, a bulbous chamber designed to withstand the crushing pressure of the deep. Its walls were so thick and heavy that the vessel could only move slowly, sinking down through the water column for hours before reaching the bottom. When it finally touched the seafloor, nearly 11 kilometers below the surface, the men inside peered through their small window and saw a landscape unlike any ever witnessed by human eyes. They stayed only a short time before beginning the long journey back to the light, but their descent marked a turning point. Humanity had set foot, however briefly, on the deepest frontier of the planet. Yet that triumph did not open the floodgates of exploration. In the decades that followed, very few returned to those depths. The reason was simple. The cost and difficulty were overwhelming. Building a craft capable of surviving such pressure was an enormous engineering challenge. Launching and supporting it required ships and crews that could coordinate every detail, and the risk of failure was constant. The deep ocean gave nothing easily, and the Trieste's descent remained unmatched for more than 50 years. It was not until the early 21st century that another human would make the journey alone. In 2012, filmmaker and explorer James Cameron piloted his custom-built submersible into the Challenger Deep, the very same trench floor first visited in 1960. His vessel, called the Deep-Sea Challenger, was a tall, narrow machine packed with lights and cameras. Unlike the Trieste, which had little capacity to document what it saw, Cameron's craft was built to capture images and samples. He spent several hours exploring the bottom before ascending again, providing the first modern glimpse into the deepest part of the world's oceans. The achievement drew headlines, not only for the feat itself, but for the fact that it had taken more than half a century for anyone to return. Between those milestones and since, only a handful of other missions have ventured to full ocean depth. Each has revealed more about what lives and thrives in those dark trenches, yet each has also shown how limited our reach remains. The pressure at such depths is so extreme that every dive risks catastrophic failure. Even the most carefully engineered machines must be tested again and again, their designs pushed to the breaking point before being trusted to carry humans. A single dive can cost millions of dollars, and the results, while valuable, represent only the tiniest fraction of what is still hidden. The reality is that despite centuries of seafaring, despite the age of satellites and spaceflight, fewer people have been to the bottom of the ocean than have walked on the surface of the moon. The handful of explorers who have descended that far stand as symbols of human determination, but they also highlight the limits that technology and resources place upon us. Each mission demonstrates not only our ingenuity, but also the vastness of the challenge. What has been achieved is extraordinary, yet when set against the scale of the oceans, it is a reminder that we have only touched the edge of a realm that may never be fully explored. When people speak of the future of ocean exploration, their voices often carry both hope and hesitation. On one side, there is the promise of technology that may allow us to go further than ever before. On the other, there is the sobering reminder that the challenges of the deep have always outweighed our ambitions. The sea has been patient for millions of years, and it is still unclear whether humanity's next wave of machines will unlock its secrets or simply skim across the surface of its mystery. Among the most talked about ideas are autonomous submarines guided by artificial intelligence. Unlike human-piloted craft, these machines could roam for weeks or months without rest, diving into trenches and crawling across the seafloor in places too dangerous for people. They would not tire, they would not panic, and they would not require constant supervision. Swarms of them could be deployed like schools of robotic fish, each one carrying cameras and sensors, sharing their findings with one another, and mapping in detail what a single vessel could never cover. In theory, this would make the impossible scale of the ocean more manageable, breaking it down into pieces small enough to study. But even the most advanced robots are still bound by the environment they enter. Batteries drain quickly in the cold, and delicate circuits corrode in salt water. Every mile deeper means pressure that tests every joint and every seam. A single flaw in design can mean the quiet end of a machine, lost forever in the dark. While artificial intelligence can guide and adapt, it cannot yet overcome the sheer physical strain of the abyss. For now, these dreams of swarms and fleets remain more in laboratories and prototypes than in practice. The conversation about the future often circles back to money. Pure scientific curiosity has rarely been enough to fund grand exploration of the deep. Instead, many of the new technologies being developed are tied to industries that see the ocean as a resource. Deep-sea mining, for example, is presented as a way to harvest valuable minerals from the seafloor, materials needed for electronics, batteries, and renewable energy systems. Companies are investing in machines that can travel to abyssal plains, scoop up nodules of rare metals, and process them at the surface. Some argue that this could incidentally lead to better mapping and understanding of the deep, as mining operations would require surveying large areas of seafloor. Yet there is a tension here. Exploration, driven by profit, is not the same as exploration driven by wonder. Mining machines are designed to extract, not to observe, and the fragile ecosystems of the deep risk being disturbed before they are even understood. What little we know about hydrothermal vents and abyssal habitats suggests they are home to species found nowhere else on Earth. Scraping machines across them for minerals could erase life forms before they are documented, erasing pages of Earth's memory forever. The question lingers. If the funding for exploration comes from exploitation, will it ever count as true exploration? Some hope rests with collaborative science, where nations and institutions share data freely and work together. International projects using networks of sensors, floats, and autonomous vehicles already monitor currents and track climate change. Expanding these networks with more advanced tools could provide a fuller picture of how the ocean works without placing profit above preservation. Perhaps swarms of AI-driven submarines will one day serve not industries, but humanity as a whole, acting as scouts that chart the unknown with the sole purpose of knowledge. Still, the ocean's immensity casts doubt over all of these visions. Even if fleets of machines crisscross its depths, even if every mining company funds research as a side effect of their projects, the sea will remain too vast, too dynamic, and too hostile to ever be fully conquered. The future of exploration may bring more glimpses, more details, more breathtaking discoveries, but the horizon of mystery will always move further ahead. What we face is not the promise of a complete map, but the possibility of knowing just a little more. Whether that is hope or illusion depends on how we approach the deep, as something to exploit or as something to respect, a place where every discovery should be treated as a fragile gift. And as we imagine what might come next, the ocean continues to wait, as it always has, holding more than any swarm of machines or network of sensors could ever reveal. There is a quiet question that lingers behind every expedition, every blueprint for a new submarine, every dream of mapping the last hidden corners of the Earth. Should we explore everything? The drive to know is deeply human. It has carried us across deserts, over mountains, and into space. Yet the ocean presents not only a challenge of scale and technology, but also a challenge of philosophy. In the dark waters where so much life has evolved unseen, discovery and destruction may come hand in hand. When we think of the unknown, it is easy to imagine it as a puzzle waiting to be solved. But the ocean is not a puzzle box. It is a living system, complex and fragile. In places untouched for millions of years, ecosystems have formed that depend on delicate balances. The slightest disruption, the light of a camera, the scrape of a machine, or the extraction of a single mineral deposit could alter those balances in ways that cannot be undone. To open every door is to risk shattering what has survived in the dark without us. This creates an ethical dilemma. On one side lies curiosity, the urge to see, to know, to expand the boundaries of understanding. On the other side lies restraint, the recognition that knowledge gained too hastily may cost more than it offers. Some scientists argue that mysteries themselves are a form of protection. By leaving certain parts of the ocean untouched, we safeguard them from interference, from exploitation, and from the unintended consequences of exploration. The question then becomes not whether we can explore, but whether we should. There is also the matter of perspective. We often treat exploration as a conquest, a way to extend human presence into places that existed long before us. Yet the ocean does not need us. It thrives with or without our observation. Its memory is recorded in sediments. Its species adapt to crushing pressures. Its cycles continue endlessly. Our presence is the anomaly, not the constant. To imagine that every corner must be opened, every secret revealed, may say more about us than about the ocean itself. At the same time, withholding exploration is not simple. Curiosity is not only a desire, it is also a tool. Knowledge of ocean currents helps predict storms. Studies of deep-sea microbes may lead to medicines that save lives. Discoveries of new species add to the richness of our understanding of biology. These are not small gains. They remind us that exploration can bring benefits, not just risks. The challenge lies in balance, in pursuing knowledge without trampling over the very wonders we seek to preserve. Philosophers of science sometimes speak of a right not to know. It is an idea that mystery itself holds value, that there are spaces where unknowing is a form of respect. The ocean tests this idea more than almost any other frontier. If a trench hides species that have never seen the light, do they gain anything from our arrival? If a cave has remained sealed for thousands of years, is breaking it open truly discovery, or is it loss disguised as progress? These questions do not have simple answers, yet they deepen the way we think about the relationship between humanity and the natural world. Perhaps the greatest lesson the ocean offers is humility. For all our satellites and submarines, we remain small against its immensity. The unknown is not a void waiting to be filled, it is a mirror reminding us of our limits. The decision to explore or not to explore is also the decision of what kind of species we choose to be, one that consumes every mystery until nothing is left hidden, or one that allows some secrets to remain held safely in the dark. And still, the pull of curiosity remains. The ocean hums with it, tempting us with whispers of species not yet named, landscapes not yet mapped, and histories not yet uncovered. But perhaps its greatest gift is not in what it reveals, but in what it withholds, inviting us to wonder without possession, to respect without intrusion, and to see mystery itself as part of the story of life on Earth. For all our progress, for all the steel and circuitry we have lowered into the depths, the ocean still holds more mystery than any frontier we have ever faced. We dream of conquering the seas, of charting every trench and recording every life form, yet the seas will always remain bigger, deeper, and darker than us. They are not only a place on Earth, but a reminder of our limits, a reminder that some wonders will always outpace our reach. It is easy to think of the ocean as familiar. We see its surface every day, rolling with tides, shining under the sunlight, and we imagine that what we see is all their island. But below that glittering surface lies a world more alien than Mars, a vastness where mountains taller than Everest rise unseen, where rivers of current carry the memory of climates long past, and where creatures drift in shapes and colors stranger than any artist could invent. Every time we push into that dark, we return with something new, yet those discoveries only widen the horizon of what we do not know. There is a humility in this, and also a kind of comfort. The ocean's mysteries remind us that Earth is still alive with secrets, that even in an age of satellites and supercomputers, wonder has not been exhausted. The sea continues to hold stories older than humanity, written in sediments and whispered through currents. It shelters species that have never seen the light of day, and it guards landscapes that may never be touched by human eyes. It is both a cradle of life and a vast abyss, both a source of sustenance and a realm of silence. As we reflect on this journey through its depths, it becomes clear that exploration is not about conquering, but about listening. Every ghost sound recorded on hydrophones, every flicker of bioluminescent light, every glimpse of a strange new creature is the ocean speaking in fragments. We can gather those fragments, arrange them into patterns, and learn from them, but the whole will always remain larger than the sum of what we can hold. That truth is not a failure, but a gift. It means the ocean will always have more to give, more to show, more to remind us of the scale of life and of time itself. And so, as this story of the deep draws to a close, the ocean continues as it always has, endless and unbroken. It waits in silence, holding its memory, sheltering its creatures, shaping the fate of the planet above. What lies beyond our reach may never be fully known, but it will always call to us, stirring the same mix of awe, curiosity, and humility that has drawn sailors, scientists, and dreamers for centuries. If you have found yourself carried by this journey, I invite you to join me again in the future as together we wander gently through the mysteries of science. A simple like, a soft tap of subscribe helps this little corner of curiosity reach others who may be searching for wonder in the quiet of their night. And if you would be so kind, share your thoughts in the comments. What do you think lingers in the deep? What secrets of the sea feel most haunting to you? Every voice adds to the conversation, just as every drop adds to the ocean. This channel has become a gathering place for dreamers scattered across the world, each of us connected by tides of curiosity. And it is always a joy to see where you are listening from and at what hour of the night or morning you drift into these stories. Now the sea will go on, endless and unknowable, and we will carry its mystery with us. For though we dream of exploring every corner, of pulling back every shadow, the ocean will always remain vaster than our reach, deeper than our tools, and darker than our imagination. It is, and will always be, Earth's greatest frontier,